So, good afternoon, ladies and gentlemen. I am Chandrakant from EDS Technologies, and I'll be your host for today's webinar. First and foremost, we thank each and every one of you for taking your time and joining this webinar, Accelerate Projects by Getting Your 3D Models First Time Right. I would like to begin the webinar by a short introduction about our company, EDS Technologies. EDS Technologies Private Limited is incorporated in 1994 to focus on providing PLM solutions, implementations, and support. We are largest technology solution provider in India and also platinum partner to Dassault Systems. We have served more than 2,000 customers across India and operate in 9 locations across India with our headquarters in Bengaluru. We have strategic partnerships with world leaders like Technia for ensuring product data quality, EOS for additive manufacturing requirements, Human Solutions for ergonomic solutions for automotive and aerospace industries. For military applications, simulations and training needs, for aerospace and defense segment, we have partnered with MAC for visual simulation solutions. We have a strategic partnership with ESRI for GIS requirements. With respect to EDA solution, we closely work with Synopsys. We have dedicated sales support, marketing, and customer satisfaction team to address customers' PLM business and support requirements. So in today's webinar, we are joined by Mr. Harman from Technia, Mr. Sushil, and Mr. Nagappa from EDS Technologies. So just a small introduction about Mr. Harman and our team. Mr. Harman Bauer's journey at Technia Software started in 2009, providing him with over 10 years of experience in field of CAD and PLM. Since 2021, Harman has served as the global sales leader responsible for Technia software solutions tailored to enhance the experience of Dassault Systems software users. Harman has been dedicated to streamlining business and delivering value to clients through innovative software solutions. His passion for Technia software lies in making life easier for customers. Our second speaker is Mr. Sushil. Mr. Sushil Punaskar has more than 20 years of experience in automotive engineering design and development. He has worked with major automotive OEMs in India, Europe, like Tata Motors, M&M, FCA, Volvo Cars, McLaren to name few. He specializes in BIW design and development, composite carbon fiber BIW design, automotive ergonomics and occupant packaging. He is currently working as a senior solution consultant at EDS Technologies for QChecker, Ramsys, Kava Solutions. Our third speaker is Mr. Nagappa. Mr. Nagappa has more than 7 years of experience in multiple domains, such as product development, technical support, functional consultant, and technical documentations. He specializes in CAD and product lifecycle management solutions. He has various global certifications from Dassault Systems. He is being associated with EDS Technologies as Senior Application Engineer and supports various our customers. So I think we can good to start now. Over to you, Harman.
Great. So then, welcome everyone from Karlsruhe in Germany. So thanks for joining this meeting. Today we will talk a little bit about QChecker and what it can bring to the benefits of data quality in engineering design processes. Let me, as a start, maybe introduce Technia software a little bit. So Technia, just as EDS Technologies, is a global partner for Dassault Systems solutions, and we are roughly 800 people in Technia, and of which is 150 to 160 people are working in the research and development as well as service of our own products. And these are distributed through Sweden, Germany, France, UK, Slovakia, India, Japan, and the US. We have strong knowledge within our team for CATIA, Enovia, 3D Experience, and also extending into the other domains. Likewise, we have 50 resellers and partners for our global coverage. Looking at this global coverage, I mean, I mentioned the countries already. Obviously, we are having to work and are glad to work with partners in the areas where we are not having our home bases. So EDS Technologies has been our distribution partner for as long as I can think and as long as I have been with Technia, and I'm quite happy for having this relationship. So a little bit about what we as Technia Software do. Obviously, we are trying to help customers that are on the Dassault Systems solutions, as well as a heavy focus on automotive and aerospace supply chains. So we are active in these areas: 3D experience deployment, collaboration such as integrations into 3D experience, but also in data exchange, migration of data. Then we have neutral process formats like a whole portfolio around the JT format. We have then, of course, the engineering data automation and validation. So about that we will talk today with QChecker. Then virtual testing, homologation of cars that might also affect you in your daily work. And then PLM operations. So we help customers setting up their CATIA workspaces. We'll come to that as well. And we are active in MBSE. So looking at the core products that are important for today, we can maybe concentrate on what you see in red on the left side and one of the blue ones. So I will go on we'll go over these in detail. As well, we have on the right side X40, which is a data exchange solution that we heavily promote in the supply chain to exchange data with in between partnering companies, or basically when you have to deliver data to your OEM. This is a great tool to streamline your process. So looking at them in detail, on the left side you see CABA, that is used for car homologation and basically helping our customers to stick to the global regulations in car design for passive safety, exterior safety, interior safety, vision, and overall car design. In the middle we see XCompare. That is our offer to compare CATIA parts, products, and drawings, able to find any difference between two model revisions. So that is often used in data exchange to find out, okay, what kind of change did I get from my engineering partner? Is it at all important for me? And then, of course, also in documentation of those changes. On the right-hand side, you see probably the leading CATIA Star tool that enables on-the-fly setup of CATIA environments. So when you work with CATIA and you have to serve several customers, you may end up with several CATIA environments in different releases with different add-ons, with different licenses that you need to use. And of course, you may also work in other CAD systems like NX, SolidWorks, etc. And that can of course be a burden for the administrator to keep all of those up to date. And here's a tool to manage this, so you can decide before you start CATIA what additional software you want to start. You see what license configuration is currently available. This is also some of the areas we work in, just to give you an idea what else there is. And then, as I mentioned, the data exchange and neutral data use. Left side, X40 for data exchange. So sending forth and back CATIA data, potentially doing a QChecker run in this system. And on the right side, our JT portfolio that is heavily used in the Daimler supply chain, for instance, since Daimler switched to NX. And they also allow the delivery of JT data. And from that relationship, this portfolio emerged and has grown into other areas as well. So coming to QChecker, I will give a brief introduction before I give on the presentation to EDS again that go into detail on the product. But just from our perspective, maybe why we came up with this and what is this? Why is it actually happening? So when QChecker emerged already a very long time ago from also another product that was provided by us, the challenge was that we had more and more products had to be developed in a very short time, and then of course the teams grew and grew and grew. So maybe, I don't know, something that happened 30 years ago only in Germany now is a global project. And you somehow have to ensure that this the flow of data throughout your process is perfect, is not broken, is not leading to additional time, and overall the strive was for reducing the cycle times throughout the product life cycle. And the benefits of having it in place is that you ensure reusability and support the concurrent engineering, that you keep the delivery dates, that you don't repair things, yeah, basically meet the targets for proper process and design. And of course, when you get clean data, the trust and reliability in partners and suppliers grows. So, and that I think for us as suppliers to the global automotive and aerospace industry, it is important that they trust us and that they can be sure that they get good data. So when we look at this in the process, and maybe one of the reasons why also OEMs are usually asking for using a tool like QChecker, might not be QChecker, there are other CAD systems, so they have other quality tools, but the basic idea is I want to visualize here. So let's say we have a process chain here within a company, or maybe across several companies. Every one of us is working on something, and let's say the blue bar represents the time we work on something. Now, in the best of cases, the blue time is used on exactly what we love and what we want to do. And now we imagine that the designer on the left, he starts the process, he works his blue bar. Obviously, he's doing what he loves in the best case. But he doesn't really know what is the what are the expectations from the follow-up processes. And if he is not respecting this, well, naturally there will be some time used that is represented by the red time, where other engineers need to understand what his intention was, or they need to figure out with him how to prepare the model in such a way that, for instance, the FEA works. And then something usually comes into play that we call methodology or CAD standards. And the magic behind QChecker is, of course, not QChecker itself, but it's the methodology. So if we give these rules out to the first designer and he can stick to this methodology, then the overall process time can be reduced and the delivery is faster. So this the reason why OEMs are asking, or in general why it makes sense to stick to the CAD standards, is basically this time saving potential that lies in this. And QChecker is just a very good, easy tool to roll out methodology and CAD standards within a company or across companies in a supply chain. Looking at the product itself, we have QChecker itself that is running during CATIA runtime in CATIA V5 and CATIA V6, CATIA 3D Experience. Sometimes you want to ensure that everyone is using QChecker and you want to understand which of the models in PDM system are already checked and clean. For that, there is an integration for PDM systems. And you can also have statistical evaluations of check results by writing the check results in a database to see if there's a need for training of the engineers. So in summary, most important, upper left corner is basic methodology definition and rollout. You define your CAD standards or you get CAD standards from your engineering partner, and QChecker is helping you to apply these. Of course, QChecker is also enhancing the user productivity that we will probably see in the coming slides. Basically, it helps you to detect these issues. That's why it's used to roll out the methodology, because a designer can then immediately see, okay, I have a problem here. There's no need to open the CAD standards catalog and have a look in this. It's right there, just like the spell checker in Word. Then, of course, the monitoring and the PDM integration. So with this, I think I can hand it back to Sushil.
Thank you, Herman, for this introduction of Technia for softwares. So myself, Sushil, good afternoon, ladies and gentlemen. Let's dig into the basics of product data quality and how it makes sense in engineering business and engineering operations. So it's a PDQ, or product data quality, is a measure of the accuracy and appropriateness of the data, combined with the timeliness with which those data are provided to all the downstream users across the line or down the line. So both are our customers, like across the line and down the line. From this, we can state that it's a means of providing the right quality data to right people at the right time, and all this we are doing with the intention of saving time, cost, and efforts, and eventually the main outcome of a business to be sustainable and profitable over the period. From here, let's take a quick look of the for say it's a car that I'm showing here, but it can be any product that can be sold and used. So we start with a concept and we go through a lot of engineering designs, CE, load case applications, manufacturing, and production. So from here, we can say that the data generates right here at the concept stage, and it goes up to the production stage. On these stages, our typical automotive development cycle is around 30 to 36 months. And this data generates here and it goes up to here. So this much data is applicable to, and it is important all through these life cycles, like product confirmation, all the important design releases like V0, V1, V2, FDJ, final data judgments, and SOP and launches. So that is the importance of the data centrally to all the internal and external customers. Now, in industry, there is a buzzword called CAD is a master. Now, in any kind of dispute between the cross-functional teams, everyone will refer to the data. Nobody will believe in any mails or communications or SMS or chats, etc. So, CAD is at the center. CAD is used by many multifunctional cross-functional teams for maker. It can be tool makers, it can be internal team who are doing the stamping engineering, mold flow engineering. It can be internal logistical teams who plan their stacks and pallet system to carry the actual finished goods. Testing teams, tolerancing teams, and these all make use of your data. Any discrepancy or any wrong information or poor quality in the data reflects any of these or some of these, but they consume time and iterations and a lot of problems when the wrong data quality reaches them. With this, let's take a small example. Like there is an imported curve, for example, the door aperture curve, maybe the front door or rear door, and that is taken and it has a discrepancy in the curve level, tangent continuity level, and surface has been drawn from this with the discontinuity. The surface is faulty. Even the post-operation will become all faulty, and finally the product is a faulty with that discontinuity. Now, when this product reaches the customer, it creates a mess. It creates a mess like when this first identified here, it can be repaired in 1 minute. If it is identified at the surface level, it could be repaired in 5 minutes. If it is identified in post-operation, 15 minutes, or maybe at the product level before releasing, 15 or 20 minutes. But if reaches the tool maker, then the tool maker will outright remove this or throw this back to designer, because his tool quality will affect by this data quality. So he will never accept that. And that is a big mess, because a normal engineering release time takes around 2 to 3 months to release the data. So that 3 months, you just counted the time value of the time lost. So that is huge cost involved just due to the poor data quality. And this is not just one example. It's you take it hundreds of parts in a car or in a product. That is multiplied by those many hours of delay in the product. It's a huge cost incurred. Now let's check some how in usual day-to-day business, how we do quality checking of a CAD. Like we have CAD release checklist, we have pre-delivery checklists, we have drawing checklists. All these are done to ensure that the right quality reaches downstreams. So, but it has certain issues, like it's a manual checking process. It's a repetitive, monotonous process. It consumes a lot of time. It kills the designer time, which could otherwise have been used on the quality. I mean, actual focusing on the real design work. So as such, it's a do and check method. These all things like a reactive method of doing checking. While the modern method is, and the contemporary method or modern method is to check while doing method, which is a proactive method. And the problem with this can be that new designers may not be aware that there is some Excel file is lying somewhere in someone's center location. So he can start his own methodology itself and maybe really realize later on in the process that he has made a big mistake. And of course, as a classic example, there are always release time pressures, and we always say there is no time for PDQ. We have to just release our designs. But out of this, as a company, we can have all this accumulated inside a CAD standard of any company, officially documented. And these two things, either of them or both of them, can go into QChecker as it is, and we can build those checks directly into the CAD QChecker application by making a suitable profile for that checks. And this all repetitions can be removed with the integration of CATIA on QChecker. And QChecker as such has 400 plus checks written by one of the expert teams, CATIA users in Technia. They are ample, they are very deep and very ample. So we can choose any checks that are enlisted here and make our profiles and do all this, pass on these all stuff onto the Q checker to handle, and thereby save our time and do the real quality work of designing the things. One example, like one very standard example, like there's a parameter in CATIA that there's a check in Q checker that checks whether any CAD part has a typical parameter added or not. So for example, there's a aluminum material parameter is added and it has certain mass to it. So now this parameter can be integrated into PDM system, and then it can be used to many users. Like the CAE team can run their scripts and they can extract the attributes like material, thickness, and etc. etc. And then they can go ahead with their own calculations. DMU team can make some interesting pie charts, like what are the typical metals being used in our product, and prepare that for the management reviews. And thickness charts they can prepare. Even the weight charts they can prepare. Metallurgy team can make use of these parameters, like they can understand is there any new material that any designer has suggested that we don't have in our database or we are not ready with. So that early information can trigger to them, they can start preparing accordingly. It is very useful for vendor development, like they can start sourcing their activities, like which is the cheapest one supplier, which is the closest one, who has the highest prices, etc. etc. So these all things can be just implemented with the help of this one parameter, which is can be integrated in, can be checked in the QChecker profile. Second application, like we have paints on our products, and that paint is a costly affair. It's a costly material. No wastage is allowed or something. And a paint shop engineer must want to know that how much paint quantity is consumed by a product. For example, it's a BIW. It can be any product. And there can be some parameter who checks with the surface area of the product. and it can offset that paint offset by, suppose example, 0.4 or 0.3 millimeters outside, and by that we know the paint material gravity, and that we can know the weights of the paint that is going on the body, and hence the cost also. So just a simple parameter can do a lot of work, which can be, and QChecker can help you build this functionality and robustness in your CAD part. Another check, like in product data quality, we always say there are geometrical checks and methodology checks. And as such, 20% importance is to the geometrical checks, but PDQ is all about methodology checks. What we just discussed a couple slide back. So what are the typical geometrical checks, like position sketches are used or not in the design? We know from engineering side that if position sketches are not used, it can completely turn the sketches upside down, left to right, and completely create the CATIA update issue. Access system is used or not. Access system is must to use, because we always derive our all engineering details from that access system. We can keep a check, like the designer should never cross any certain limit of the model size, for example 50 MB or 5 MB, so that he can focus on very robust and sensible modeling approach towards the design. Checks can be implemented to hide all the planes, points, curves, lines before saving the object, so that when third party opens it, it opens in a very clean environment. It can also, QChecker can also check like the 3 to 1 datums, like 6 datums we have in any component. They are in order or not. For example, there's X1, X2, X3, and designer has given X2, X2, X1, X2, and Y3. That is a completely redundant datum philosophy or datum strategy. So QChecker can even check whether the datum sequence has been given properly or not. It's a very important check. Many mistakes can happen here, and if it goes to manufacturing or assembly team, then it can create a mess at their location strategy. It can check fake dimensions, etc. So there are a lot of geometrical checks. I will not go through all, but 80% weight is given to methodology checks, like how we use QChecker to add that parameters, etc., to build a robust methodology inside CATIA. So these are a few changes that we, some points we saw just a couple of slides back. Benefit of one classic example from Europe, customer had around 5 million euros of expenditure just due to poor data quality, and he was incurring this much cost due to some mistakes that happened in the CAD, and these were growing. The costs were growing, and they implemented QChecker in this location in 1919. 1 year there were no gains, so less users, no major users, but eventually when users grown all over the company, all over the departments, then suddenly the quality of the data starts improving, and the repair cost came down. So if you see here, in the 5 years time, they have reduced the repair cost by around 75%. So that's the robustness and powerfulness of QChecker application. Some typical checks, like we can build in checks in QChecker, like what should be hidden, what should be shown while saving the component, so that when we open the data, it opens in very clean model with no invisible surfaces or no show items there. Then we can also build checks like all bodies should be properly named, so that a component designed in maybe Europe can be completely or very easily modified by an engineer in America or even in India. So that modeling strategy, building strategy can be implemented. QChecker can check whether this naming has been given or not. Let's take some example, one interesting slide that showcases our relevance, why we should always stick to product data quality as a modern tool to increase productivity. In very old days, we used to have these drafting and etc. 2D drawing generation. Many times in the previous, we used to have this verniers and calipers to use actual measurements by inspection engineer. We are very conversant or very comfortable with coordinate dimensioning and tolerancing system, very understandable, very easy to explain, very easy to understand, but it has its own drawbacks, as we know. And then we have in the same lines, we have this catalyst checklist here, where we maintain all checks one by one down the line in the Excel file that every designer is supposed to see and verify his designs. But now this is old story. Now is the CAD designs. We all do CAD designs. We don't think of now creating this drafting drawings, etc. Similarly, nobody in inspection scenario now checks by vernier or something. They always go for gauges and CMMs and etc. That's a modern way of doing things. Similarly, we can nowadays the shift is toward the geometric dimension and tolerancing, because it offers almost more than 50% more tolerance without doing anything. So people have understood the why GD&T is important. So that shift we have made in the industry. Similarly, whatever time consumingness or very repetitiveness or monotony, we can pass on this all mess for QChecker to solve and just spend our quality time in doing the engineering work, which is important for business. So that's how the QChecker really makes sense in the modern day-to-day world of engineering. Yeah, some example checks I would like to take what QChecker can do for you in engineering scenarios. It can, for example, here is a stamping component, maybe an underbody component here. It has some warping or folded surface created by designer. And as a trick, with some trick, he could successfully thicken this component. So nobody knows that there is a glitch in the component surface level. So, and then this component can reach stamping engineering, and he can outright reject this due to poor quality, because he cannot offset this surface, he cannot make a tool surface out of it. That's a problem for him. Fake dimensions can be readily identified in QChecker if you build that check. This in a lot of companies we have start parts to start with any new designs. So there can be checks like some bodies can be empty when we take a new start part. There can be check build according to that. Then there can be bare minimum publications in the component here that is must. QChecker can check that these surfaces are published or not. Then when you publish the item, the parent item should always be hidden. That's a basic rule in CATIA. But any designer can make it visible and both surfaces can get shown. That's a problem. So and in textual dimension, overwriting dimensions or text can be easily identified by QChecker checks, and it can report as error. Yeah, this is very example, very good due to it's a minimum wall thickness check. Like for example, any bumper design or in plastic component design, we do a lot of Boolean operations. So due to any Boolean operation, if the thickness at that location goes drastically low and designer never notices it, then it can go to supplier and the supplier creates a tool out of it. It can create a filling issue quite high there. The breakages can happen in durability tests. So that this check is a standard check in QChecker. It can check that. Voids, it can check the voids inside so that the weight calculations are properly on the component. Tangency checks can be readily checked inside the surface. And G1 discontinuity like sharp edges can be checked. Tangency continuity there is a readily check available in QChecker. We can implement that readily. Intersecting surfaces, solids can be easily identified with the help of, otherwise we will never notice them in real sense unless we didn't notice that. Yeah. Perfect. It can also correct your structure of a CAD product. It can make it in order, like the instances it can put in the right order so that it looks clean and neat and not it doesn't look in a messy scenario here. Just like the previous one, there's some surface glitch here, which can be identified by QChecker so that it's an early indication to surface the designer that he should go and correct the location or the local surface here, and so that this it can be repaired. As I said, G1 checks can be at the curve level and at the surface level. It can check it. This is a classic example, like the previous datum strategy has changed for the component and the designer is missed to remove this previous datum. So any redundant datum or deactivated datum, queue checker can check easily and give it as an error in the queue checker, so that it's just a removal operation for it, just a 1 minute job for engineer. Otherwise, it will reach to assembly team and he will report as error. Then there is a rule in FTA that the capture's name should always equal to the view's name for correlation purpose. That can queue checker has a check, ready check for that. This is a classic again, for example, like the thickness. When we give the part, the red arrow should always pointing toward the material direction. If it points toward the other direction, then the thickness can reverse. And unfortunately, if the tool is made, then the tool has to be scrapped, because the A side will become B side and the B side will become A side of the surface of the part. That is a big mess in terms of cost and time. It can identify fully constrained or under constrained or maybe free surface, unconstrained geometries in the sketch. It can check also whether the complete part body is in working object or any middle operation is working object. This can go, if it is saved in this manner, this level of data will go into the PDM system and it can show an incomplete data in the PDM. We can check, we can also put criteria like how much model nomenclature character length will be. So for example, 25 length character we can allow. We can set according to our requirements. Clash detection is a beautiful check in QChecker that can readily check the clashes in assembly mode, which it also has a CATIA also has this tool, but it's always good to have for this, because this is more makes sense to check here. QChecker can, with the help of this healing operation, it can completely make this not good looking surface final product into this clean model here. Yeah. And from here, I'll say maximum document file can also be saved, can also be given a limit, like you cannot increase certain amount of part size in a CAT part. It can also check whether the text in the drawing is derived out of a parameter or not, or designer has given it in typed himself and written this check, written this standard number. That also check is available in QChecker. Yeah, these are all some interesting. These are just few. I mean, as I said, there are 400 plus checks written by expert CATIA users, CATIA team inside Technia, so they can be readily implemented. Let's check what is queue checker. So it's basically what Herman said. It's just a reiteration of the same. It's a company in Germany that used in conjunction with Dassault system, CATIA softwares, primarily used in ensuring quality and compliance of CAD data and models. It also helps in user to maintain CAD standards and detect errors early in the process, so that downstream a lot of time and cost can be saved. It started with very few checks in 1990 when it first implemented. Then it grown to implementation in CATIA V5, a lot of new checks added, and in 2009 it got collaborated with added in for V6 also for dedicated customers. Globally, it has more than 1,500 companies that are customers of QChecker who readily use it in day-to-day operations for their product data quality. They are automotive industries, aerospace, machinery, and consumer goods also. These are some examples, some client lists, like we have automotive car manufacturers here, aerospace and transportation domain car manufacturers, and some aerospace companies also. And interestingly, over 1,500 global suppliers are actually the suppliers, tier 1 suppliers and engineering service companies who make use of QChecker. That's interesting, because if you see the quantities, 50 and 1,500, it's quite a huge numbers. And as such, we speak about India, we have some big names like Tech Mahindra, Ola Electric use it, Ultron is there, Lear Corporation use it. EDRI is using it, Varroc is using QChecker. So these are just few, they're using it. And by this, I end my last slide here. I'm now requesting Abhay to take over. Thank you, everyone.
I think we'll have a quick demo by Mr. Nagappa. He will showcase us about the entire QChecker software. How does it look like? What is the GUI? How the checks are performed in a quick manner. Yes, Nagappa, I think we will
Yeah,
be short
yeah.
of time. You can finish quicker.
Sure, sure, sure. Thank you,
Thank you.
Harman sir, and thank you, Sujal sir, for the detailed explanation of the PDQ system with the detail, with the example in the global example as well. So for the live demonstration, I have opened the OEPI application. So currently, I'm using the 2022 release. So it's a small like when it comes to the integration, this is the PDQ system with our native V5. Post integration, will have additional these toolbars. So let me run a quick run with the example. Let me go with some example. Okay, so I'll just let's see. I have opened a small model for showcasing a live demonstration. So you can see a model I have created with all the construction elements and the surface axis, few of the operation elements, and also solid elements as well. The solid where includes some deactivity features and the axis system when it comes to the numerical master geometry, few of the surfaces, followed by publication as well. So through just by naked eye, it looks fine. The model is created, everything looks good. Let me run this huge PDQ system. We will see how it throw the errors with respect to this particular model. Okay, just we need to do just need to select this particular icon. Okay, me open this. So as Sushil sir explained in a do and check the reactive method how the company is following. So these are the common checks where all the companies are using. So that the list of checks that need to be checked for every engineer when it comes to a design standards. So this is about the coordinate system standards, naming parameters, seat metal parameter, bend radius. So these are the common checks that need to be checked for all the parts. Maybe it's a product, maybe a part, maybe seat metal part, composite part, electrical system parts. Okay, so this is a consolidated list of a checklist for the design. Maybe take it to the next company. So this is one more checklist the company is following. So this is the company again segregated when it comes to part design, when it comes to assembly design, when we title block, the drawing, all these are different checks. The company, every engineer need to follow. First is go with post creation of the model. He need to go with the self review for all the checks like do and check method need to check each check when go to model whether it's properly done or not. So it's very time consuming when we need to check with all these files. Again, suppose when everything's done, we going to send this to the final review, the maybe an industry, maybe a supervisor, a technical lead, or maybe other person, other principal engineer. Okay, we'll see like how it useful when it come to the design checks. Okay, so the similar checks have added here. So this is a PDQ solution. After clicking this, we have an additional window. Just we need to select a environment. When it comes to environment, maybe engineering service provider for the different domains. Maybe it's aerospace domain, maybe a locomotive, maybe automotive. Okay, when it comes to aerospace, maybe let's say Airbus is one of the company, or the Boeing is one of the company. Okay, maybe Bombardier, maybe other companies. Again, when it comes to Airbus, we do have different variants. Maybe we are working for the A220, A330, maybe some extra body 900 and 1000, maybe A330. So when we are working for the model, we need to run a proper checks which is related to that project. Okay, again, when it comes to a Boeing, we do have like different variants in Boeing as well. Maybe the as an engineering service provider, we used to work for different variants. Maybe again we can see the B737, 747, 787, different like. Again, when it comes to the automotive, let's say take example of Olo. Olo will have a Q checker list, maybe for various different pieces system. There are some design standard that need to check. Okay, this particular profile will contain a checks which are very similar to your manual checks. Okay, the list of checks what you are following here. It's an automated tool which contain all the checks. Okay, let me run just a simple run for this particular model. Just click on the run check. Okay, so here it's showing the in order 0 because this particular environment which I selected, it contains a 0 checks. Okay, just loading. Here you can see the model I created with the FT as well, the annotation sets, all these things. Okay, for the live demonstration purpose, I'm just created a demo profile. So this is the window. Here I need to just select a particular environment. The environment contain a profile which is contain a number of checks. Okay. Post that it generates the report as well, the detailed report of this particular checks. Let me run this. So we'll see how we throw the detailed report. Can you see these are the list of checks? Okay, the few checks are in order as per our company standards. You can see it's in green color, and if you are in a yellow color, it's stating some warning. Okay, if you are like you're not even following, it's saying the now note, it's not following your design standards. Okay, let me take you one by one. Can you see this particular the root part name must match the packet part. You can see here this particular D53, but you can see the part document. This is position 23 extension. Both are not matching. Okay, just like we have a healing option, as which is explained, we have healing option just by clicking this. Okay, it'll just automatically rename both the names. Okay, now it's moved to the in order. Now go back to the there's only one profile in the solid features. This particular thing here, the pocket will contain more than one profile. You can see this, the pocket 9 contain a 9 profile, but as per my company standard, design standard, in a single sketch there should be only a one profile, but in particular a pocket 9 will contain more than 8 profiles. So it's stating the warning, so this is not allowed in my design standards. Again, can you see this, the non-allowed CATIA version and releases? So it's not even, this is also violating our standards. So here we have information like the allowed release are less than 2020, but the release for one which are using this is 2022, because we are working like engineering service provider. We need to send the same model to our customer. The customer and our release should be same, so that it's very it should not, it leads to some complication when you go with the different releases. To avoid that complication, just go with a proper lease. Okay, when it comes to a link document, you can see this particular, the unlinked material is not allowed. So this particular thing we have applied, but it's following the unlinked material. So all material should be linked. When you're trying to fetch and apply the material, that has to fetch from proper directory. The directory one which you're following or your customer following should be same. Now this is also violating here. Okay, when it comes to a healing option, we do have a healing in a quick check. We all know, like in surfaces, the healing option it's also violating. So what, see, as a engineer, he is very new to this particular PDQ system. He's very confused, but like, why it's not following even though I am following up the standards. We have a automatic online help document so that you can follow it, so the end user can get a detailed report for how this check does, what is the useful of these checks. Okay, we do have this also. Okay, the merging distance for this particular hill is 0 to 0.08, but when you open this, maybe it contains more than that. So that's the reason it's not following our design standard. When I expand it, as visual expand, it checks the peak dimension as well. When FTA, these three dimensions are peak dimension. We do have this healing option. Either you can delete it or you can restore the value. Just expand it. Okay, just selecting this, we can go with these two options. I'll go with the restore values. Okay, now all the criteria are restored. Now this particular check it moved down, it's following in order. And also I have a empty body. So in particular my design side, I'm not going to allow any empty bodies in my tree structure. Now you can see that this reference is an empty body. So with the healing option, you can just delete it. No need to go back and delete it. Okay, and also have this thing. So when your model get done, you need to send your model that your part body only this particular should be in working object, so that it will highlight all your design features. We have this option. So currently it's not this construction element in a working object. Go with this particular healing option. Now this thing get in work object. Okay, again you can see here the few of the elements still violating. Just you can explore one by one. You can see the permitted element in types in show mode. Okay, now you can see here this particular model are highlighting with your plane, point, surface, everything. But at the end, once the model is created, only you need to set a solid element that need to be shown in this particular. Okay, with this you can just hide which are not required with the healing option. You can see all the elements get hidden in a hidden mode. Also, you can see the publication name must match the publication element. But currently, you can see these two are the publications. So these two are element. It's highlighting somewhere here in NMG. The name you can see this is _1, but the publication it is not _1. Here the checks are stating it's not following a similar name. So with the healing option, you just click on rename. The both are now matching. Okay, in a very little time, both the particular checks get following our design standard. Okay, you can see one more thing, the visualization state of the publish element. Currently this publish element is in a show mode. Okay, just by clicking this it will go back to a hidden mode. Okay, and similarly you can see the sketch not fully constrained. So these are the list of sketch which are not fully constrained, but in a as you know that what is a complication when you go with a under constrained or a not fully constrained, how it leads to problem in a design things. Okay, so these are the list of sketch which are not fully constrained. It's highlighting these are checks which are not fully constrained. Okay, for this we don't have any heal option. We need to go back and heal it. This is about thing. And also we have a deactivated features. So your created models end up with this particular features holds all this thing, but we have this number of deactivated features. So again it leads to problem. It leads to when you go with the EBOM creation, there'll be a variation of the weight. Okay, maybe your customer will not accept this particular model because it contains a number of deactivated features. When you try to edit it, it may lead to complication one to one because there will be a relation between one feature and other features. So either in a healing option, we have two options: either you can delete it or you can activate it. Okay, this is how we can run a queue checker. Okay, now you can see this is the list of the checks which are now allowing like following as per our design standards. So this is just a simple model I'm just showcasing. Maybe you're working with a very complicated model with so many checks. It's very, I'm just adding a very few checks for this particular model. Let me run the same thing for the drawing. Okay, let me run the same thing for the drawing as well. You can see the drawing looks fine. This have a number of views. Maybe it's just through naked eye you can see just asking for the update. We have a additional sheet, detail sheet, and 2D elements, all these things. Okay, let me run a queue checker for this drawing as well. It's loading. Okay, and I'll just following the same environment file for the drawing as well. Let me run it. We'll see how it works. So you can see, so these are the checks which are not following as per our standards. Maybe just a quick run. We have healing option for the permitted text points. We need to follow a proper points per our drawing as well. Just go with this. Now it's following. Let's move down. It's following our this thing. This is permit text going in order. Then go back to the locking view. Currently, our views are not in a lock order. You know, all are showing. Just by clicking this, all view get in a locking mode. Okay, you can see the peak dimension. Maybe through naked eye, it's very difficult to identify what are the peak dimension when it comes to a reviewer, because very difficult, because the reviewer used to review maybe every day 5 to 10 models. It's very difficult to identify what are the peak dimensions. So with a queue checker, it's very easy to identify. Here we have two options: either you can delete it, you can restore back to the original value. Make you just go with the one dimension. Okay, this the value of this is 4.99, but with a with peg you maybe try to round up the value. Just go with this and restore the all the value. Now you can see all in a drawing, all the values are restored back to the original values. Okay, maybe you can see the it contain AMT detail view has just deleted, which are not required. And few of the here you can see the views are active mode, but in a drawing it not supposed any active views. Just go with this option. Okay, and few of the non-up-to-date dimensions. So all dimensions should be up to date, should not be any it asking for the update all these things. Just click this. Even you can see few of the things like it's going out of the view frame. So we need to put everything in a single when you select a title frame or thing, everything should be fit in within the view frame. Okay, now these two views are coming out of the view. Maybe we don't have any HAL option, we need to go back and restore it back. Now we can see, so these are the list of checks. So all are like following just in a few seconds, just few clicks, all are following as per our company standards. Okay, as Vishnu sir explained, going with the reactive method, doing actually taking a lot of time, not only for the end user, the designer, it's also for the final reviewer and the owner. He need to send the same amount of time for all the models. With the help of PDQ, in a lesser time, you can rectify all your errors. So this is how we can run a Q checker. Okay, so this is just a live demonstration related to the PDQ system. You can run for the different model as well, not only for the part trying, the NC programming, even for the system engineering and the product as well. Okay, it produce a detailed report as well.
So good. I think very informative session by our all speakers. I would like to thank Harman Sushil Nagappa for delivering this webinar. I'm confident that it was helpful to our audience as well. I would like to also thank audience for taking their time out and joining up this session. If you have any further queries related to the subject or any other simulation requirements, you can always connect with us. Our details are displayed, yeah, on the screen right now. You can reach out to us anytime. We will be happy to address your queries. Please do keep an eye out on our upcoming seminars and webinars. So you can follow us on social media for same. Thank you once again for joining us today.